Sa video natin ngayon, we will discuss this problem using the 3-moment equation. And then to make things simple, let's just use the shortcut formulas for the 3-moment equation factors and then using the method involving integration. Para isang formula lang yung gagamitin natin for concentrated or distributed loads. So in this problem, using the 3-moment equation, we have to calculate the deflection at B and also the deflection at C. So we have the beam section, 200 mm yung width niya, then the depth is 400 mm. And then the modulus of elasticity is 200 gigapascal. So ito yung simply supported beam natin. And then recall na sa 3-moment equation, we are to pick 3 points along the elastic curve. And then the value of H1 is the vertical distance from point 1 to point 2, assuming that point 2 is below point 1. And H3 naman is the vertical distance between point 2 and point 3, assuming that point 3 is above point 2. Ito yung basic assumption. So if downward yung deflection according to the elastic curve, then point 1 and point 3 are above point 2, then we can apply the 3-moment equation. Else, if the second point is above the first or third point, then it will yield a negative sign para sa H. Then L1 and L2 naman are the horizontal distances separating point 1 and point 2, then point 2 and point 3 respectively. Now, sa problem natin, we have the same moment of inertia and the same modulus of elasticity throughout the section. Hindi kasi siya non-prismatic. Therefore, we can apply this 3-moment equation which assumes that E and I are constant. Then 6A1 barred A1 over L1 saka 6A2 barred B2 over L2, yan yung 3-moment equation factors. But again, we can just use this formula. For any point load located along the span, let's say this is P, then this distance from the left is equal to A, tas ito naman equal to B. So for 6A1 barred A1 over L1, the general formula is PA multiplied by L squared minus A squared divided by L. Then for 6A2 barred B2 divided by L2, we have the formula PB. Lahat ng A dyan, palitan mo lang ng B. So times L squared minus B squared, then divided by L. Ito yung 3-moment equation factors. Then we can apply integration if the load is uniformly distributed, uniformly decreasing, or uniformly increasing. Now looking at the figure, once we draw the elastic curve, lahat ng loads natin are downward and then the beam is simply supported. So naturally, this beam will deflect downward. Like this. Ayan. So parang ito yung elastic curve ng beam. And then at point A and D, walang deflection dyan since andyan yung supports natin. So for the first question, to calculate the deflection at B, we can assume 3 points. Ideally, the 2 points must be located at the support since alam natin na walang deflection dyan. So we can pick point A as our first point. Then we have point D as our third point. Then the point where we want to take the deflection, yan yung magiging second point natin. So for the first question at B, andito yan. Aligned to this point. So therefore, this is our point 2. So ngayon, the vertical distance between point 1 and point 2, this would be our H1. Ayan, H1. And then the vertical distance between point 2 and point 3, draw tayo ng line dyan. Ito yung magiging H3. Ayan. So try to notice na H1 and H3 would be equal since point 1 and point 3 are along the same elevation. Nasa supports kasi sila. So our first assumption is H1 is equal to H3. Ayan. Now in the 3-moment equation, M1 and M3 are also 0 since they are located at the left end and the right end. Walang movement dyan. So, M1 equals 0. M3 is also equal to 0. So, yung need na lang natin i-compute would be M2 and also the 3 moment equation factors. So, ngayon, let's solve the reactions first of the beam. We have here AY and we also have DY. Ayan. So, to solve AY, we can sum up moments about point D equal to 0. So, we would have AY multiplied by the moment arm, which is 5 meters. Then, minus 10, since this will cause a counterclockwise rotation, then our moment arm is 2 meters. Then, we have minus the resultant of the triangular load. So, this is 1/2 times the base multiplied by the height. Ito yung resultant load. Tas, yung distance na to, patungo sa point B, this is 2/3 of the base, which is 2. Ayan. So, 2/3 of 2 plus 1 plus 2, yan yung moment arm niya. So, kopyahin na lang natin. 1/2 times 2 times 15. Ito yung resultant. Then, the moment arm is 2/3 of 2 plus 1 then plus 2. Ayan. Then, we can set this to 0. Input na lang natin sa MathCAD. So, solving AY, we would get 17. So, store lang natin yan dito sa AY. Then, summation of forces vertical equal to 0. We have this force, AY, acting upward. Then, we also have DY. Ito. Also acting upward. So, plus. Then, minus the resultant of the triangular load, which is 1/2 times base times height. Then, minus also the concentrated load, which is 10 kilonewtons. Ayan. So, equate to 0. Solving dy, we would obtain a value of 8. So, gagawin natin ngayon, since we already have ay and dy, sulat ko na lang, 17 kilonewtons, then ito naman, 8 kN. So, taking the moment at the second point, which is point B, we would have 17 multiplied by 2 meters, which will cause a clockwise rotation, then minus 1/2 times base times height, or you can just obtain this value. This is just equal to 15. Then the moment arm going to point B is 2/3 of 2. Ayan. Or to simplify this, dito ko na lang sa MathCAD i-input lahat. So, M2 is equal to 17 times 2, then minus 1, 15 na lang yung matitira. Magka-cancel kasi yung 2 dyan. Then, multiplied by 2/3 of 2. So, press equals, we have 14. So, this is a positive internal moment. So, applying the 3-moment equation, we have M1 equal to 0. So, we will proceed to 2 times M2, then multiplied by L1 plus L2. Now, what is L1? The value of L1 is the horizontal distance from point 1 to 2, which is 2 meters. Ayan. Then, our L2 is the horizontal distance from point 2 up to point 3, which is 2 plus 1, 3 meters. Ayan. Then, M3 is 0. So, M3L2 will not yield a value. Then, we will just add the 3-moment equation factor. So, let's first start sa first span natin, which is point 1 to 2. Now, sa point 1 to 2, we need to compute 6A1 barred A1 over L1 for span 1. Then for span 2 naman, 6A2 barred B2 over L2. So we can apply this formula para sa first span. But since we have a triangular load, we have to apply integration. So we can consider a differential strip. We can label this as dx. And then as I explained sa previous videos natin, kapag meron kang triangular load, trapezoidal load, it's best to start your origin doon sa point kung saan 0 yung height ng triangle. So 0 yung height ng triangle dyan. This would define my distance x patungo sa strip natin. Then the height of the load at this particular point, label natin as y. So by ratio and proportion, let's consider the small triangle. The height is y, the base is equal to x. Then equals the larger triangle, yung buong height niya is 15. Then the horizontal distance is equal to 2 meters. So 15 over 2. Therefore, expressing y in terms of x, we have y equals 15 over 2 magiging 7.5 multiplied by x. So this is the height at any point x measured from B. Then integrate natin para isum up natin lahat ng effects niya. So for 6A1 barred A1 over L1, we would have integral from 0 to 2. Bakit 0 to 2? Dito tayo nagsa-start, then we will end dito sa point A, which is 2 meters in length. Then applying this formula, we have P times A. So the load would be equal to the height, 7.5x. Ayan. Now what is A? A is the distance measured from the left. So if this is x, I hope na agree lang that this distance from the left going to the strip, diba, this would be 2 minus x. 2 meters yung buong distance na yan, then minus x. So we have PA. Move ko na lang to. Dito na lang. So P times A, then L squared minus A squared. The length of this span from 1 to 2 is equal to 2. So 2 squared minus A, which is 2 minus x, then squared. Then we have to divide this by L, which is 2 meters. Then we have dx. So 6A1 barred A1 over L1 is equal to the integral from 0 to 2. Then we have here 7.5x multiplied by 2 minus x. Then 2 squared minus A squared, 2 minus x squared, divided by 2. So check na lang natin yung value na yan. This is equal to 14. So yung 14 na yan, you can obtain the same value using this general formula. So yung triangular load natin is uniformly decreasing. Then we are calculating 6A1 barred A1 over L1, which takes this formula. So 7WL cubed divided by 60. So if we will try to input, our load W is equal to 15, then the length is equal to 2. So 2 cubed divided by 60. Then press equals, we would still get 14. But again, so that you don't have to memorize all of these formulas, then just apply integration, then ito na lang yung kailangan mo. Isang formula lang para sa concentrated load and all distributed loads. Kahit ano pa yung figure. But if you prefer to memorize, then you can still do it. Do what works for you. So remove ko na lang yan. Again, this is just for checking. So the first 3-moment equation factor is 14. Then the second one, 6A2 barred B2 over L2 can be obtained by using this formula. The load P is equal to 10. Then since this is the second span, we have to calculate 6A2 bar B2 over L2. So the value of B is equal to 2 meters. We are now considering this span. So from the right, this distance is equal to B. Ayan. So 10 times 2, then L squared minus B squared. So we have 3 squared minus 2 squared. 3 meters kasi yan. Yan yung L. Then divided by L2, which is also 3. So input natin yan. This is equal to 33.33. So para exact yung value, copy ko na lang. So plus, ito yung 6A2 bar B2 over L2. Then equals, we have 6EI. Now again, when solving the deflection, since EI is constant, then we can just treat it as 1. So gagawin mo na lang, 6 times, remove EI, ito. And then the reason we're doing this is para mas madali yung conversion mamaya. So times na lang, since H1 and H3 are equal, according to our figure, we can just label this as H. So, yung H na yan, yan yung deflection at B. So we have H sub B divided by L1, which is 2 meters. Ayan. Then plus, still H sub B divided by 3 meters. Ito yung value ng L2. So solving H sub B, we would get 562 over 15, which is equal to 37.467. Now this value is still in K and M cubed divided by EI. Now since we have our beam section, we can calculate I. Then we also have E. So the deflection at B, or delta B, is equal to this value. Ayan. Or ano na lang, label ko na lang as H sub B. Then lagay na lang natin dyan H sub B. Again, naka K and M cubed yan. So times 1000 to the 4 para maging Newton mm cubed. Then for this beam section, di ba, we have to divide this by EI. The value of E is 200 gigapascal. Now multiply this by 1000 para maging megapascal siya, Newton per mm squared. Then multiplied by the moment of inertia in mm to the 4th, the base is 200, the height is 400, then cube, BH cubed over 12. Ayan. So press equals, we have 0.176 mm. This is the deflection at B. Ayan. Now let's proceed to the second question. Calculate the deflection at C. Now for this question, we have two options. We can use what we obtained from the first question and then pick 3 points accordingly. Or we can just change our second point. We can move it to point C. But for my first solution, ito na lang yung gagawin ko. I'm not certain if this point is above point 2 or below it. So we have to assume first. Now gagawin ko, this point along the elastic curve below point C, label ko yan as point 4. Ayan. So ngayon, in the 3-moment equation, I will consider points 2, 4, 3. Ayan. So we now need to compute, bale, M2, L1 plus second point is M4, 2M4 L1 plus L2, then plus our third point is M3. Again, we are considering the following points. So M3, L2, then plus 6A1 barred A1 over L1, then plus 6A2 barred B2 divided by L2. then equals, teka lang, move ko lang, 6EI, then H1 over L1 plus H3 over L2. So yung mangyayari dyan, if we are to consider the following points, highlight ko na lang. Ayan, if we are considering these points, then magkaka-value na yung M2. Diba? Kasi yung M2, yan yung nakuha natin kanina, which is, sana yan? Ito, 14. Now, how about M4? What is the value of M4? To calculate the value of M4, we can either take moments from the left or from the right. But if from the right, you have to change the sign. So, for example, we have point C corresponding to M4. So, dy times 2 meters. Now, this will cause a counterclockwise rotation. But again, since we are taking moments from the right, change the sign. 8 times 2 is equal to 16, counterclockwise, so magiging positive yan. So, M4 is equal to 8kn multiplied by 2. 16. Now, taking moments from the left, you don't have to change the sign. But yun nga lang, mas mas complicated. Now, if you want to check, we can also calculate M4 by taking moments from the left. So, AY times 2 plus 1, 3 meters going to point C. 17 times 3. Then minus, the resultant of the triangular load is 15. Then moment arm going to point C is equal to 1 meter plus 2/3 of 2. So 1 plus 2/3 multiplied by 2. Press equals, we have 16. So same lang yung value. But again, it must be positive. Since by convention, yung moment natin sa Sheehan moment diagram is drawn from left to right. Kaya kung from the right ka, you have to change the sign. Kapag counterclockwise yung rotation, magiging positive. If clockwise naman, magiging negative. So ito lang yung dapat mong tandaan. Now, point 3 naman is still equal to 0 since this is at the right end. Now, how about the 3-moment equation factors? For the 3-moment equation factors, this is our first span. Diba? From point 2 to 4. So, if we are to draw it, parang ito siya. 10 kilonewtons. Then, diba, gagawin natin yung simply supported. So, essentially, wala tayong 6A1 barred A1 over L1 because if you try to look at the formula, if the value of A and L are the same, then this part of the equation will be equal to 0. Kasi diba, ito yung A, which is essentially 1 meter. Span 2 to 4. Ayan. So, equal yung A, ito rin 1 meter. So, walang 6A1 barred A1 over L1. Now, 6A2 barred B2 over L2 naman is also non-existent because B and L are also the same. If you will draw span 4 to 3. So, span 4 to 3, we would have the following figure. Andito yung 10, then this is 2 meters. Kapag gagawin mo yung simply supported, the only reaction that will come out is andito lang. 10 kN. Same sa first figure. So, wala ring 6A2 barred B2. So, this is the reason why, if merong dependent question, then we can use the deflection we got from the first question. Mas maganda siya. Mas efficient siya na solution. Since wala nang 3-moment equation factors na kailangan. So, solving the deflection at C, it's very simple. We have M2 L1. Again, refer to this equation. Ayan. So, M2 times L1. L1 is equal to 1 meter. Then, plus 2 M4. Yung M4 natin is this value. 16. Tapos, L1 plus L2 would be 1 plus 2. 1 meter, then 2 meters. then wala ng 3 moment equation factors, automatic na yan, equal to 6EI times, now sir, what is H1 over L1? Yan yung hindi natin alam. So actually, yung H1 dyan is this value. From point 2 going to point 4, zoom in ko na lang. Ito yung H1. Essentially. Vertical distance from point 2 to point 4. Now, in our figure, we are assuming that the middle point is above the first point. So, therefore, H1 must yield a negative sign. Sa assumption natin, but hindi pa natin alam kung below ba siya or above point 2. So, we would now have negative H sub 1. Then, this horizontal distance from point 2 to 4 is 1 meter. So, divided by L1. Then, point 3 is above point 4. But what is the vertical distance separating them? Diba, hindi yan H3. Ito yan. From point 4 going to point 3, the vertical distance is this one. Ayan. Now, I hope agree lang that this is H3 minus H sub 1. Ayan. So, ito yung vertical distance separating point 3 and 4. So, we would have plus, then H sub 3 minus H sub 1 divided by the second span from 4 to 3, which is 2 meters. Now, we want to solve H sub 1. But we have 2 unknowns since wala tayong H3. But thankfully, na-solve natin yan kanina. Yan yung deflection at B. Diba? This vertical distance is the deflection at B. Ayan, yung nakuha natin kanina. Which is this value. H sub B. So what if label ko na lang to as H sub B. Ayan. Then solving H1, we would obtain this value. 0.267. Now, it came out to be positive, meaning our assumption is correct that 0.4 is above 0.2. Now, what if we made the wrong assumption? What if yung drawing natin is parang ganito? Yan, what if ganyan yung elastic curve? Di ba kapag ito yung assumption natin sa elastic curve, 0.4 would be below 0.2. So, gagawin mo dyan, ipapositive mo lang yan, yung H1. But if you will try, if this is positive, then what would happen here? Diba, this will also change. Bakit? If this is our elastic curve, then 0.3 going to 0.4 will not be H3 minus H1 anymore. Let's say lang na this is our assumption. So, parang ito yan. From 0.2 to 0.4, let's say this is our wrong assumption. Ayan. Ito yung magiging H1. Then this distance going to the third point, vertical distance, this is what we label as H3. So ngayon, if this is our figure, then magchi-change yung equation natin. Bale, H1 over 1, then magiging positive yan. Now, this distance naman is equal to the deflection at B. Ayan, di ba? H sub B yan, going to 0.2. So, in our equation, this distance H1 is essentially equal to H sub 3 minus H sub B. So, ngayon, yung magbabago lang, H sub 1 will be equal to H sub 3 minus H sub B. According to the figure. Minus H sub B. And then our sign is positive because 0.4 is below 0.2. Then for the other side, we have H3. Then for the other side, from point 3 to point 4, we have h sub b plus h sub 1. So, modify na lang natin yung equations according to h. So, ngayon, the distance between point 2 and point 4 is equal to h sub 1. So, h sub 1 divided by 1, and then this is positive because in this assumption of the elastic curve, point 4 is below point 2. Then, from point 3 to point 4, the vertical distance is h sub b plus h sub 1 equal to h sub 3. So, h sub b then plus h sub 1. So, press equals, we would get negative 0.267. So, ngayon, the negative sign here only indicates that we have the wrong assumption. So, meaning, 0.4 pala must be above 0.2, which corresponds to our first assumption kanina. So, remove ko na lang to, since this is the wrong assumption naman. Ayan. But kita nyo naman, whether or not nagkamali yung assumption, the same pa rin yung value na ibibigay. But I'll just modify this back sa first equation natin. Negative h1 over 1, then hb minus h sub 1. 0.267. So ngayon, the deflection at C is equal to h sub b minus h sub 1. Teka lang. Di ko pa pala na-store. Ayan. So, 37.2. But this is still in kn m cubed over ei. So, divide this by ei. Same lang kanina. Ayan. Then, multiply this expression by 1,000 to the 4. So, the deflection at C pala is 0.174. So, diba, this is lesser than 0.176. Kaya, yung point C is above point B pala. Now, alternatively, diba, sa equation natin kanina, we solved H1 first, and then, ito yung value ng H sub C, essentially. Yung deflection at C in Kn times m cubed. However, if you want to obtain H sub C right away, then we can modify this one. Diba, if we are to check our figure, redraw ko na lang para mas malinaw talaga. Ito yung naging assumption natin. Ito yung 0.2, this is 0.4, ito naman yung 0.3. Then we know this value, from 0.2 to 0.3, the vertical distance is equal to h sub b, yung nasolve natin kanina. Ayan. Then from 0.4 naman, going to 0.3, this is the value of h sub 3. Then from 0.2 to 0.4, this is the value of h sub 1. So ngayon, if you want to solve h sub 3, since yan yung deflection na kailangan natin, because h sub 3 is the deflection at C. Diba? So, we can also express the equation para ito na lang yung unknown natin. So, essentially, h sub 1 is equal to h sub b minus h sub 3. So, we can modify this equation. Bale, negative pa rin yan since 0.4 is above 0.2. But this will become h sub 3 or ano na lang, h sub c. Modify ko na lang to. Ayan. H sub 1 is equal to h sub b minus h sub c. So, parang ito na yan. H sub b minus h sub c. Then, from 0.3 to 0.4, the vertical distance separating them is equal to h sub c. So, change this one into h sub c. Then, solve h sub c. We would automatically get 37.2. So, ito, pwede mong palitan yan. H sub c na yan agad. Palitan pala natin to. Ayan. We would still get 0.174375. Same lang. So, let's try to check using our deflection app. Then, solve natin ulit yan mamaya, considering 0.143. Bale, first point, second point, third point. Pwede rin yan. So, calculate muna natin yung I. I is equal to 1.067 times 10 to the 9. Or in decimal form, ito yan. So, 1.086. Then, 0.667. E equals 200. Then, model natin yung beam. The span is 5 meters. Then, we have a triangular load from 15 to 0. Then, 2 meters. Tapos, simply supported. $10,000 and then 2 meters. Ayan. So, ito yung deflection. Click lang natin. Then, let's move it to point B. Now, point B is 2 meters from the left. Ayan. We would get 0.175625. Which is this one. 0.176. Now, change natin yung number of decimals into 5 decimal places. Ayan. So, 0.17563. Or this is essentially 625. Ayan. So, same lang. Then, for point C naman, point C is 3 meters from the left. So, we have 0.174375. Same lang dito. Ayan. So, tama na yung mga sagot natin. So, ngayon, with the alternative solution, let us consider points 1, 4, 3. So, lagay natin dyan. Now, the value of M1 is 0, saka 0.3 rin. Still equal to 0. So, we would have 2 times, our second point is M4. Then, L1 plus L2 is equal to 3 plus 2. This is our L1. 2 plus 1, 3 meters. Bale, yung first span natin is 1 to 4. Then, the second span is from 4 to 3. Considering points 1, 4, 3. Ayan. Now, for this solution, the first span will look like this. Ayan. Then, this is 10kN. Tapos, 15. 2 meters, then 1 meter. Now, itong 10 kilonewtons, if this is to be simply supported, when calculating the 3-moment equation factor, nakasagad yan sa support. So, wala siyang 3-moment equation factor, yung 10 kilonewtons. So, wala nang silbi yan. Ito lang yung i-compute natin. Then, since this is the first span, we have to calculate 6A1 barred A1 over L1. Now, what's going to change sa figure na to? Move ko na lang yan. Essentially, we can apply this formula pa rin. Ayan. Yung value ng A natin is still 2 minus X. From the left end patungo sa point of application ng load. Pero, yung L natin, instead of 2, this is now 3. So, palitan mo lang to. 3 squared, then divided by 3. So, ito yung equation na yan. 3, saka ito rin. So, press equals, we have 26. So, 2M4 times L1 plus L2 plus the 3-moment equation factor for the first span, 26. Then, for the second span, since ginamit na natin yung 10kN sa span 1 to 4, for span 4 to 3, wala nang loading dyan. Ito yan, span 4 to 3. Yung 10 dyan, matatanggal na since ginamit na natin siya sa span 1 to 4. So essentially, 6A2 bar B2 over L2 would be equal to 0. Ayan. Then equals, we have 6EI times H1 over L1. So equal lang yan, H sub C divided by the length of the first span, 2 plus 1, 3 meters. Then plus H sub C divided by the second span. So solve H sub C. We would get 37.2. Which is, di ba, same lang kanina. Yung nakuha natin na value was 37.2. H sub B minus H sub 1. Pakita ko lang Ayan. 37.2. So again, alternatively, the deflection at C is equal to ito na lang, H sub C. Then same parameters pa rin kanina. So 0.17435. Same lang yung dalawa. So nakadepende na lang sa inyo kung ano yung mas prefer niyo na solution. Madali lang din to if you will apply integration. So wag mo nang split yung loadings ng dalawang spans. Matatagalan ka lang. Just use the 3-moment equation factors, then apply integration when needed. So I hope na meron kayong natutunan, and salamat sa pagkikinig.